My name is Margit Messmer and I work here at the University of Leeds in the School of Mathematics. In this video I would like to talk about solving inequalities. I'll present a few examples, talk about a few principles, in particular about the modulus, involving the modulus sign also. So what does it mean to solve an inequality? Let's first look at a very simple, easy example, which you probably are familiar with, something like 6 minus 2x is less than 4. Actually, I wanted less than negative 4. So solving such an inequality, what do? We apply operations to both sides of the inequality with the aim of isolating x. So in this case, you would, for example, add 4 on both sides. You get 10 minus 2x less than 0. Then you would add 2x on both sides, and you get 10 less than 2x. And then you would divide by 2 and get to 5 less than x. And so we see that all x satisfying this inequality are exactly those x which are greater than 5. Now, I've written down these 4 lines without connecting them. So in mathematics, it's very important to make sure that we actually read these as statements and connect the lines together. So what we want to say is that if this is true about x, then this is true about x, then this is true, then this is true, and vice versa. We want to go upwards as well. So what we want to actually do is connect these 2 lines by the statement that this is true if and only if the next line is true, and so on. So it's important that we connect those with if and only ifs, often indicated with a double arrow sign and abbreviated by an IFF. So in here I'll do this for every single line. So we need to make sure that we can go in both directions. Now, if you take this equation, this inequality, I could have done something slightly different. I could have, for example, subtracted the 6 as a first step. So I could have taken 6 minus 2x less than negative 4, and now subtracted 6 on both sides. So this would give us a minus 2x less than negative 10. And again, as an if and only if. Now I could divide both sides by negative 2 and get x. And we know that if we divide by negative 2, we need to change around the inequality symbol. And you see you get the same solution here as we get here, x greater than 5. When I learned in school about solving equations or inequalities for the first time, it was all about learning about rules and operations that can be applied to both sides of the equations. And there were lots of rules like, well, if you multiply or divide by a negative number, you need to switch around the inequality symbol. When you square things or take square roots, you need to be careful, you need to check your solutions and things like this. And I always found it slightly mysterious where these rules came from and what the underlying principle is. So instead, before looking at more examples, I want to try and identify what the underlying principle here is, because this will then allow you to tackle lots of other problems. So let's just look at the very first step here. So in the very first step, what we did is we added 4 to both sides of the inequality. What we did really, we applied a certain function, namely the function f, which takes x to x plus 4 to both sides of the equations. Now, what is it about this function that allows me to do this and not change the inequality symbol? Whereas here, let's take in the last step here, what did we do? We applied the function f, well, we divided by negative 2. That means we applied the function x goes to negative x over 2 to both sides of the equation. What is it about this function that forces us to switch around the inequality symbol? Well, let's just draw a little graph here. This function, if this is the point 4, the graph of this function looks roughly like this. The graph of this function looks somewhat like this. what is the major difference? Well, this function is increasing, this function is decreasing, and that's exactly what is the reason for having, in this case, not to change the equality symbol, whereas in this case we have to. So I'll write down what it means for a function to be strictly increasing and strictly decreasing. So a function f is strictly increasing if for all little a's and b's in the domain of f, it means we need to make sure that f is defined for both of these values, we have that a less than b implies, in other words, we have this implication symbol, that f of a is less than f of b. Right? So if, for example, here's little a, here's little b, then this is f of a, over here is f of b. So this says if I take two values, a less than b, and then compare their images, then f of a is less than f of b. And you see that for this function it's just the other way around. If I have a and b here, f of a is now larger than f of b. So I can here also right away include the definition for f being strictly decreasing. So that means that if a is less than b, this implies that f of a is greater than f of b. Right? Now you see that this implication here is exactly what we need to go from one line to the next. And not in the case of a strictly increasing function, not changing the symbol, in the case of a strictly decreasing function, changing the symbol. Please note that we also for each of these lines, we need to be careful that we also can go the other direction. So for example, going from this line to the line above, what we do is we apply the inverse function. In this case, it would be we're subtracting -4, x goes to x minus 4, but that function is an increasing function as well, so the same principle applies. Okay, so what's the moral of the story here? Well, solving inequalities, when we apply these operations to both sides, we need to keep an eye on the function we apply and the question whether this function is increasing or decreasing. We also need to be careful whether these functions are defined for the values we apply these functions to. You also realize now that when we apply functions such as the square function or the square root function, that we might run into problems. So if you look at the function which takes x to its squared, right, a basic parabola, this function is decreasing for -x and it's increasing for +x. So if you're sure that you are somewhere on the right hand side here, we can use one principle. If we're applying the function to negative values, we can use the principle for the decreasing function, but the problem comes if we're applying it to values we don't know whether they are positive or negative. With the square root function, well, the square root function is defined for all non-negative x, and it's a nice increasing function, so there's no problem we won't have to change the symbol there, but we need to make sure that the function is defined at the values we apply a function to.